Okay, so I'm going to be doing section 14-2, question number 20, part A and C. I have to apologize, I don't have the best voice, so you have to stick with me here, but I'll try as best I can. So we're going to start by part A, and so in both of these, we're going to be finding the area of each of the following shaded regions, assuming that all arcs are circular with centers marked. So in this first one, we want to notice that the given figure consists of one large circle with two smaller circles inside. So here's our larger circle, obviously, and then our two smaller circles. And then we also want to pay close attention to the regions that are shaded. So we have up here and down here. And so to find the area of the shaded region, we are going to want to subtract the area of the smaller circles from the area of the larger circles. So first, to begin, we want to remember the area of a circle. So the area of a circle is, I'm going to quick bring this out. Our area of the circle is pi r squared. So first, we want to find the area of the larger circle. And so in order to do this, so we know that our radius is 1. And so that is going to be the same in this circle. So put 1 centimeter. So we know that the length of both of these circles then is going to be 2 centimeters. So we know that our radius for the larger circle equals 2 centimeters. So next, with knowing that, we want to do our area equal to pi r squared. So from that, we get our area is equal to 4 pi centimeters squared. So that is how we find the area there. And so then, as we move along here, now we want to find the area of one of our smaller circles. So again, we know our area. Let's do this. This is large circle. Okay, and small circle. So again, we know our area equals pi r squared. And in this case, now we want to look at just a smaller circle. So we know that's 1 centimeter. So our area is going to equal pi times our radius, which we know is 1 squared. So we know our area equals 1 pi. So now that we know that, there are 2 radii of the 2 smaller circles, and they are equal. So to find the total area of the small circles, we're going to take our area we just found and multiply that by 2. So our area of our 2 smaller circles is going to be 2 pi centimeters squared. Sorry, I kind of lost that up here. There we go. So now that we have the area of the large circle and the area of the 2 smaller circles, we want to subtract the area of the large circle and the area of the small circle to find our final answer, which is the area of the shaded regions. So we are going to take our 4 pi centimeters squared minus our 2 pi centimeters squared to give us 2 pi centimeters squared. And, this is our final answer. So that is how you do part A. So now we are going to move on to part C and do the same thing. So for this one, to find the area of the shaded regions, we're first going to relate the area of the shaded region to the area of the circle. And so we want to notice that the area of the shaded region is equal to the area of the unshaded region. So therefore, to find the area of the shaded region, we want to find the area of half of the circle. So in order to do this, we want to find the area of the larger circle to start. So again, we know that area equals pi times our radius squared. And so again, for this one, we have 1 centimeter for our radius, but for the whole circle, we want to take that times 2, and so that's going to be 2 centimeters. So our radius here, whoopsies, is going to equal 2 centimeters. So our area is going to equal pi times our 2 centimeters squared. So our area is going to equal 4 pi centimeters squared. And so now we know that the area of the shaded region then is equal to the area of the circle, which we just found, and divided by 2. So we're going to take our 4 pi centimeters squared and divide that by 2. So we get our answer to be 2 pi centimeters squared. And there's our answer for part C.